Hi, hello, this is your Lucky Sir. Periodic table assignment 2 related to the periodic table. Okay, now periodic properties assignments will start in next session. Mendeleev corrected the atomic weights of, by using the valency concept, he corrected the atomic weights of all these elements, beryllium, indium, and osmium. Zero group was introduced by Ramsay. Ramsay and Rayleigh are the scientists who discovered most of the noble gases. According to Mendeleev periodic table, the properties of elements are periodic functions of their atomic weights, and modern periodic law, atomic numbers and electronic configurations. Correct. Total number of groups of Mendeleev table are 9. Okay, those are 0, 1, 2, up to 8. In Mendeleev table, the triad of 8th group is ruthenium, rhodium, palladium. Okay. Nickel, palladium, platinum, iron, ruthenium, osmium, cobalt, rhodium, iridium. All these are of 8th group. Number of short periods in Mendeleev table are short periods. For example, first period if you take, there are 2 elements. So this is called very short period. Only hydrogen and helium. Second and third periods, they have 8 elements each. Second and third. Second one is from lithium to neon, 8 elements. Then sodium to argon, 8 elements. So these are called short periods. The properties of the following elements were predicted by Mendeleev before their isolation. Before their isolation. Isolation means before their discovery only he has given. Okay, now in that we can take the examples: scandium, gallium, and germanium. Scandium is eka boron, gallium is eka aluminium, germanium is eka silica. The number of elements known when Mendeleev periodic table is around 63. The element scandium is known long back as scandium is eka boron, eka aluminium is gallium, eka silicon is germanium. Which of the following is not an anomalous pair? Tellurium iodine is anomalous pair, cobalt nickel is anomalous pair, argon potassium is anomalous pair. Anomalous pair means they are not in the atomic weight order. So this is not anomalous pair, and this is your answer. Okay, now these are anomalous pairs. This is not anomalous pair. Key answer is this one. Long form of periodic table questions. The number of periods in the long form of periodic table is 7. The total number of gaseous elements are 11. Those are 6 noble gases: helium, neon, argon, krypton, xenon, radon. Then oxygen, fluorine, chlorine, nitrogen, and hydrogen. Total 11. Which of the following remains unchanged in descending in a group in the periodic table? Valence electrons don't change. In a group, all the valence electrons number will be same. In a period, elements are arranged in strict sequence of increasing charges in the nucleus, that is protons number you can say, atomic number you can say. Which of the following is not a representative element? Representative, chromium is a transition element. D black. Representative means this is first group, this is third group, this is calcium is again second group, all these representative elements. Mendeleev table A. The inert gas present in the second long period is Okay, now there are first period is very short period, second, third periods are short periods, and fourth period is long period. Okay, and he is asking second long period, so then you can go with this one, and that is xenon. Okay, now helium, neon, argon, krypton, xenon. Monoatomic element among the following is krypton. Noble gases are monoatomic. phosphorus is P4 tetraatomic, oxygen is O2, sulfur is SH. Which one of the following pairs of atomic numbers represents the elements belonging to the same group? Okay, this is aluminium, this is gallium, having a difference of 18. You can check 18 difference. The atomic numbers of elements, second inner transition elements, lie in the range of. Second inner transition means actinoids. Actinoids numbers are 90 to 103, thorium to lawrencium. The atomic number of elements of first transition series lie in the range of. First transition series 21 to 29, you can take even up to 30 also, but 21 to 29. Okay, 30 option is not there, so there is no worry. Scandium to copper, because zinc we don't consider as transition. In the long form of periodic table, all non-metals are placed in. Non-metals are in P block only. All elements of the same group will have similar outer electronic configuration. The atomic number of an element is always equals to number of protons, or you say electric charge of the nucleus. That is nothing but number of protons. Which of the following is not the electronic configuration of a representative element? You see, this is noble gas, NH2NP1. This is of third group. This is of fifth group. Sorry, seventh group. And this is second group. So this is not representative element. Which of the following electronic configuration corresponds to an inert gas? Outermost electrons. So this is alkali metal. This is again alkali metal, and it is of halogen, fluorine. Which of the following electronic configurations is the outermost shell is the characteristic of alkali metals? NS1 it should be. Okay, N-1, S2P6, NS1. There is no relation with the ND orbital here. 27. Lanthanum belongs to, lanthanum is of D black. Okay, now after lanthanum 14 elements are F black. Okay, now cerium to lutetium F black, but lanthanum belongs to D black. Which pair of elements of atomic numbers given below will have similar chemical properties? Same, lithium and sodium, same group, same properties. The period that includes all blocks of elements are, now it is 6th and 7th also. Okay, now this question, as I told you, these questions are little bit old textbook questions, so we are getting both 6th and 7th both. Elements with atomic numbers 9, 17, 35, 53 are collectively known as halogens. It is fluorine, chlorine, bromine and iodine. First transitional series is present in 4th period. After 4s orbital, 3d, then 4p. In iron atom, the differentiating electron enters into 3d sublevel. Iron is 4s2, 3d6. The elements with atomic number 39 to 48 belongs to, okay, now that is, you can say like this. If you know the noble gases number 2, 10, 18, 36, 54. This is first period ending element, second period, third period, fourth period. 39 to 48 you mentioned, so that comes in 5th period. The atomic numbers of lanthanides are from 58 to 71, cerium to lutetium. The first lanthanide is cerium, just now we mentioned in the question. The 4f level is successively filled up in lanthanides, 5f is actinides. Lanthanides are a group of elements in which the differentiating electron enters into F sublevel. Most of the radioactive elements are present in actinides after uranium. Okay, now 92 atomic number. All the elements are man-made elements and most of them are radioactive. Man-made as well as radioactive. The elements with atomic numbers 2, 10, 18, 36, very, very interesting number. These are noble gases. 36, 54, 86 inert gases. Helium, neon, argon, krypton, xenon and radon. Difference you see, here the difference is 8, here the difference is 8, then difference is 18, here the difference is 18, here the difference is 32. If you remember these numbers, that's enough. You can answer many questions. Which of the following represents the electronic configuration of a D block elements? 1 to 10, ns1 to 2. The general electronic configuration n-1 d3 ns2 indicates the particular element belongs to d3 and 2, like 3d3 4s2. So this is the fifth B group. Vanadium related. If the valential electron structure for an element is ns2np5, this element will belong to the group of ns2np5, means that is halogens. For inert metals it is ns2np6, alkali metals it is ns1. Inert metals you mentioned ns2np6, it is inert metals, means it is actually silver, gold and inert metals, particularly gold type of elements you need to mention. Okay, so no need to mention about inert metals. Coming to 43rd question. Variable valency is the property of transition metals and inner transition elements. Which one of the following belongs to a representative group of elements in the periodic table? Aluminium, because this is noble gas. Lanthanum is D block element. Chromium is again D block element, means transition. The element californium belongs to a family of actinide series 5F. Transition metals are often paramagnetic due to the unpaired electrons. One or more unpaired electrons is the reason for the paramagnetic behavior. This point we were discussing even in atomic structure also. A member of lanthanide is lutetium, cerium to lutetium. Which is wrong about transition metals? They are diamagnetic, it is wrong, because most of those are paramagnetic. The electronic configuration of the starting and the ending elements of fourth period are: fourth period, first element is 4s1, last element is 3d10 4s2 4p6, because 3d10 will be extra added in that one. So this is the right answer. In which of the following period a maximum number of 32 elements are present? Sixth, now seventh also. As I told you, little old questions. The element having, and generally whatever the updations are there, these updations will only have difference. Remaining all will be easy, only same questions only. Even if you are seeing last 10 years back question also, book also, there will not be any kind of difference. So coming to the element having 18 electrons in its outermost shell is palladium. Nickel, palladium, platinum. Palladium is very special in that electronic configuration. Normally nickel purpose we have 4s2 3d8, but palladium we have 5s0 4d10. That's why it is completely having 18 electrons. 4d10 5s0 na? So this is not valence for that. So 4d10 4s2 4p6, all these are filled, so 18 electrons are there. Very special electronic configuration it is. The maximum number of valence electrons possible for atoms in the second period of the table is 8. They are from lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon, second period. The atomic number of an element is 34. Then it is present in which period and which group? As I told you, just see like this: 2, 10, 18, 36. So this is first period. This is fourth period. So definitely it will be in fourth period. So fourth period, fourth, 3 fourths are there. And 34, before this 35 and before this 34. This is of 18th group. So this is 17th group. This is 16th group. 16th group is also called 68 group. So this is your answer. The position of element with Z is equal to 24 in the periodic table is 21, 22, 23, 24. Okay, as I told you, 24 again will come in fourth period only. You can see the above 2, 10, 18, 36 in that. 19, 20, this is first A group, this is second A group, this is third B group, this is fourth B group, this is fifth B group, and this is sixth B group. One more question we have here, 55th question. This will stop this session. Transition metals exhibit variable oxidation states. It is because of the energy difference between Ns and N minus 1d levels are very, very less. So electrons can jump here and there easily. Okay, rest things we'll discuss in next session. Till that time, good day.